So this is lesson 5.1b, and we're going to be factoring trig expressions. Right, and that's our directions. On all of the problems we're going to do is going to be factoring, and then simplify if you can simplify. So our first one is a fraction, kind of a super long fraction bar. The numerator is sine of x plus cosine of x. And the denominator is sine squared of x minus cosine squared of x. All right, so back when we talked about polynomials and rational expressions, we talked a little bit about terms being married. Do you guys remember that? It was kind of weird, but hopefully it helps you. Weird things help you remember. So addition and subtraction binds these terms together in marriage, and you can't cancel them unless there's another couple that looks just like them. So in this case, they both do have a sign of x, but because of the addition and subtraction, we can't cancel. But we can always factor. So the numerator won't factor. So we'll just bring it over. What about that denominator? What do we use to factor that denominator? Difference of squares. So because they're both squared and then there's a subtraction, we're going to factor them using the difference of squares. All right. Once you get down factoring, if there is a couple on the numerator that matches exactly with the couple on the denominator, they have to die, remember? Okay, so they are going to die. If everything cancels out of the numerator, what's left up there? A 1. So this is going to be 1 over sine of x minus cosine of x. And then what's different about today than the last lesson is we're not going to have choices. We're not going to be able to match, which makes it a little harder to know when you're finished. But this is it. This is all we can do. This is the answer. Now, if it had just been 1 over sine of x, we can change that to cosecant of x. But because of that subtraction sign, we cannot do that. So this is it. All right, let's look at another one. So for B, we have cosine squared of x, cosecant squared of x, minus cosine squared of x. On every one of these, we are going to factor. And typically is going to be our first step. Sometimes we may have to play around with the problem a little bit. But this one we're ready to factor. And it is the difference of squares, but there's something we're going to do first. So this is a term, and this is a term. What do they have in common? What do they both have? Good, cosine squared of x. So what we're going to do is we're going to factor out a common factor, which is cosine squared of x. I think I'm going to have to go underneath. So they both have a cosine squared of x. So we'll factor it out. So if I factor cosine squared of x out of this first term, what are you left with? Cosecant squared of x. Awesome. All right, what about the second term? 1. Good job. Minus 1. Now make sure when you do factor out a common factor, just kind of in your head, check it to see if you distributed it back out, you get what you started with, and you do. Now, anytime, and I told you guys this on Wednesday, anytime that you have a squared trig function, an addition or subtraction, and 1, it probably is going to match up with one of your Pythagorean identities. Now, we do not have an identity that has cosecant squared of x minus 1, but do we have one with cosecant squared of x? Yeah, number 11, right? But the way 11 is written right now, we can't use it. But if I move that 1 over, oh, those are you. So anytime we have cosecant squared of a variable minus 1, we can replace that with cotangent squared of that variable. So that's what we'll do. All right, and in this case, that's all we can do. We could try kind of playing around with cotangent squared, changing it to different things, or cosine squared, but it doesn't get any simpler than that form. And again, that is going to challenge you, that knowing when to stop. All right, let's look at another one. So for C, we have cotangent cubed of x plus cotangent squared of x plus cotangent of x plus 1. Okay, so think back to polynomials. If there were 4 terms, what do we use? We use grouping. So we're going to group this into 2 groups. And then we factor a common factor out of each group. So what's the common factor in the first group? Cotangent squared. Awesome. Okay, and we'll factor that out of each of those. All right, there is no common factor in the second group, but we do have to put something outside the parentheses. So what is it going to be? A 1. All right, now as long as these two match up, we're in good shape. So we're ready to finish off our factoring. So what we factored out, the cotangent squared plus 1 is 1 factor, and what was left over is the other factor, just like with polynomials. All right, so again, we have a squared trig function and an addition or subtraction with 1. That is probably going to match up with an identity. It matches exactly with the original number 11 identity. So I'm just going to replace 1 plus cotangent squared of x with cosecant squared of x. And sometimes people kind of get it in their heads that if it's not a squared term, just like cotangent of x plus 1, they can use the Pythagorean identities, but you cannot. The Pythagorean identities only work with the squared terms. Okay, we have a couple more to do. So for D, we have cotangent squared of x plus cosecant of x minus 1. All right, the difference in this one and the one we just did is we have two different trig functions, and we're not going to be able to factor them like it's written. On the first one and the second one, it was okay because we were factoring difference in squares and factoring out a common factor. That is fine. But trinomial type problems, they are going to have to be the same. So if you look at your identities, can I change cotangent squared to something with cosecant? What do y'all think? I think so. Yeah, if you use number 11 and solve it for cotangent, solve it for cotangent squared. So anytime I have cotangent squared of x, I can change it to cosecant squared of x minus 1, if that would help us. And in this case, it definitely will. Now everything else in the problem, you just go ahead and bring down. All right, and so from here, I'm just going to combine my like terms. All right, and then I'm going to factor this just like a trinomial, just like we've factored tons of times in here. So we're just going to do our two sets of parentheses. Right, and then what we're going to put here and here is going to multiply to give us cosecant squared of x. So that's going to be cosecant of x and cosecant of x. What do we know about our signs? One's positive, one's negative. So this negative right here is telling us that the signs are different in our factors. And then the only way to get 2 when we multiply is going to be 2 and 1. So we just have to decide if we want our 2 to be the positive or our 1. What do y'all think? Okay. We want to get positive cosecant of x. So it's going to be 2. All right, now I'm just going to check it. You don't have to write this down when you're doing your own work, but I just want to check. When I multiply those, I get 2 cosecant of x. When I multiply those, I get negative cosecant of x. And then when I subtract those, I get what I wanted. So that is definitely the right way to factor it. And I can't do anything else with it. So just leave it like that. Okay, this last one that we're going to do is also a trinomial. Six cotangent squared of x minus 13 cotangent of x plus 5. All right, so this one we're in good shape at the beginning because we already have only cotangents, and so it's ready for us to start factoring it. So there's a little less at the beginning of this one, but the factoring part is slightly more challenging because there's two ways we can get 6 cotangent of squared of x, and it's to use 3 and 2 to get the 6, or use 6 and 1. So if you guys were doing this without me, what would you just guess? I probably would too. Now, if it's not right, it's no catastrophe. We just subtract or just erase it and try it again. All right, what do we know about the signs this time? They're the same, and what are they? Minus. Good job. All right, so the only way to get 5 is going to be 5 and 1 to multiply. So we can just kind of play around with it to see where we need to put the 5 and the 1 to get the 13. If it doesn't work, then we can change the 3 and the 2 to 6 and 1. There's only 4 possibilities here. Is it going to work with 3 and 2? Yeah. So if I do 5 and 1, it's going to work because that's going to be negative 10 minus 13. I'm sorry. Negative 10 minus 3 gives you your negative 13. So we're good. So any questions on factoring trig expressions? It's kind of weird, but it's building on what you already know, so that's helpful. Okay, you don't have very many problems, so I think it's 6 problems. 22 through 32 even on page 355. Give you guys a heart for Valentine's Day.